So example, you will see that 1024 cross 1024. This one is the 1024 cross 1024, and this is subsample down into 32 cross 32 pixels. Means from 1024 we come to the 32 cross 32. Okay, so this is known as subsampled. Well, guys, don't confuse. This is the part two of our previous lecture. That is, we are discussing about the image acquisition process, and under image acquisition process, we have gone through Nyquist rate, about image resolution, and then spatial resolution. Okay, so now this is an example of this resolution. Okay, so this is the subsampling example from 1024 cross 1024 to 32 cross 32. Now look at this example. This first one, first look at the picture. You will see that the first one is the finer one and the last one is the, I can say, the low quality one. Why? You'll see the first one is a 1024 cross 1024 image. Okay, resolution is higher. Then this is 512 cross 512. Then this is what our 256 cross 256. Then 128 cross 128. Then 64 cross 64. Then 32 cross 32. Actually, what is that? Now, actually, we are trying to convert this image into different resampled images. As I have mentioned here, that the first one is the 1024 cross 1024 and 512 cross 512 image that is being resampled into what 1024 cross 1024, and by row and column duplications, and draw the 256 cross 256, 128 128, 64 64, 32 30. You don't confuse. Actually, whenever, just note down one point, whenever our this dimension is decreased, okay, so then we are obviously going to get lesser details image clearly. But in case suppose the original is of higher dimensional image, higher number of pixels are there, and we are again resampling it into the smaller one, okay, then this case will happen. Clear? There is a question for you, and question is that, can we increase spatial resolution by interpolations? Okay, you may write it down. Can we increase spatial resolution by interpolation? Okay, comment your answer. Now, next term is image quantization. Image quantization can be defined as a process to discretize continuous pixel values into discrete numbers. Now, with this definition, one more technical term is related, that is color resolution or color depth or levels. Color resolution or color depth or per levels is defined as the number of colors or gray levels, or number of bits representing each pixel value, or number of colors or gray levels NC, and this is given by NC is equal to 2 to the power b, and b is nothing but the number of bits. Okay, so it is totally dependent on the number of the bits used to represent that. Okay, technical term is intensity resolution. Intensity resolution refers to the smallest discernible change in the intensity level, or I can say the number of intensity levels usually is an integer power of 2. That is very much obvious because we are using the number of bits to find the number of pixels or number of intensity levels, so that will obviously going to be a power of 2. And this also refers to the number of bits used to quantize intensity as the intensity resolution. So can you tell me which intensity resolution is good for human perception? That is 8-bit, 16-bit, or 32-bit. Can you guess it? This first one is the 256 level. The second one is the 128 level. Nothing means I don't need to say that how many bits are consumed here. If it is 256 and if it is 128, how many bits are consumed? Okay, you all know that. So just find out the powers of 2, and that power of 2 will be the number of bits. Then this is the 64 bits, then this is the 32 levels, then this is the 16 levels, then this is the 8 level, and this is the 4 level. And in this image, actually it is easy to see the false color. And this is the 2 level. 2 level is what? The 0 and 1. So the word suitable is subjective, means which level the means we human will be finding it easier to understand. It will be subjective. Subjective means depending on the subject. Okay, depending on the particular image or particular object of the image we are looking at. So you can say that this image, you know, that Lina image, this is the low detail image, and this is the medium detail image. Yeah, medium detail means you will see that some informations are there in the background and this person with the camera. Then this is the high detail image, many objects are here. Okay, to find out the particular person from here, so we have to go through each of them very carefully. So this is a high detail image. Okay, so to satisfy human mind, for images of the same size, the low detail image may need more pixel. Okay, and image size increases means fewer gray levels may be needed. Okay, clear? So these questions, that what is the number of levels with respect to human perception level, this is actually subjective depending on the subject. Okay, next technical term that you should know is interpolation, image interpolation. So image interpolation is used in image resizing. And resizing, we have two famous techniques, that is zooming and shrinking, rotating and geometric corrections. These are the cases where we use image interpolation. Okay, so basically they are related to image resizing, then rotation and geometric correction. Note it down. Interpolation is the process of using known data to estimate values at unknown location. So means we have some known data, we are going to use them to find out some, or we can say that to estimate some values for some unknown location. That is image interpolations. Then we have different types of image interpolation techniques. One among them is the nearest neighbor interpolation, and it assigns to each new location the intensity of its nearest neighbor in the original image. Means nearest neighbor means, suppose if x is the point, we may fill the x value in the x plus 1 location. Okay, so produce some undesirable artifacts such as severe distortion or straight edges. So this has some disadvantages, that it may produce some undesirable artifacts like some distortion of straight edges. Why? Because we are just using the known location value to put in some unknown locations. Okay, so that is nearest neighbor interpolation. Then we have bilinear interpolation. Here we use the 4 nearest neighbors to estimate the intensity